Hi, second graders. Today this week we're going to be working on Lesson 9 in our instruction book, and Lesson 9 is about solving one-step word problems using two-digit numbers. So we're going to first start out with just a one-step word problem that we're going to try to solve, and I want you to use your best method to solve this problem. So first I'm just going to read it to you. It says, Simon has a piece of ribbon 85 inches long. He needs only 67 inches for the tail of his kite. How much ribbon will be left once he cuts off 67 inches? So I want to show you that I have given you the equations. So we could look at this as either 85 minus 67 and get the answer by using subtraction, or we could flip it around into an addition problem and count up. We could say 67 plus some unknown number will get us to 85. So those are a couple different equations that you could use to solve this problem. And I'm also wanting to draw your attention to the bar model that I drew over here on the side of the page. And we're going to be using bar models this week. We'll be using bar models to show totals and parts of the totals. And we're also going to be using number lines and equations to solve our problems this week. We will not be drawing pictures of tens and ones models, so when you go to solve this particular problem, I do not want you to use a drawing of tens and ones models. But I do want you to pause the video right now, and I want you to figure out the answer to this question. How much ribbon will be left once he cuts off 67 inches from the total of 85 inches. So pause the video and figure that out now. Okay, I hope that you have solved that problem, and I hope that you found out that the answer was 18 inches is what will be left after he cuts off the ribbon off, after he cuts 67 inches off of his ribbon. So this is one way that I solved the problem, and you may have done the same thing. You may have done a number line like I did. I did an adding up number line because my arrows, my arrows go in the direction of adding up. So as you can see, my arrows are jumping up the number line. All right, so this is adding up. And my equation I decided to do was 67 plus what unknown number equals 85. So I started at 67, the lowest number, and I hopped 3 spaces to get to my nearest 10, which was 70. And then I hopped another 10 spaces to get to the nearest 10 closest to 85, which was 80. And then I just had 5 left, so I hopped 5 more to get 85. When I add those 3 numbers, my hops together, I have 3 plus 10 plus 5, and those numbers add up to 18. So I know my missing number was 18. So that was one way that I solved the problem, and maybe you used a number line. Another way that I chose to solve the problem, let me go to my next picture. All right, another way I chose to solve the problem was I just simply used the expanded method of writing out my equations or writing my numbers. So instead of 85, I know that 85 can be broken up into 80 plus 5, and that 67 could be broken up into 60 plus 7. It is a subtraction problem. So when I looked at it, I could tell that 5 take away 7 was not going to work because the 5 is a smaller number than 7. So I knew I had to do regrouping. So I took away 10 from 80 and I got 70. And I added that 10 to 5 and got 15. So now I could do my subtraction. 70 minus 60 is 10, and 15 minus 7 is 8, and when I add those two numbers together, I got 18 inches. So that's how I was able to get the answer to this problem. And I hope that you found that the answer was 18 as well. All right, so what we're going to do now is we're going to be looking at our page in our instruction book. So you should be on page 80, and if you need to pause the video while you're getting that page, that's fine. But I'm going to go ahead and read our first story. We always read together and make sense out of our problem. So this problem says, Mr. Soto's students can trade 75 box tops for school supplies. They have 49 box tops. How many more do they need to get to 75? So we need to solve this problem, and let's see what our page says to do first. All right, so I noticed that they are showing us a bar model over here. Okay, so they want us to fill in the missing parts of the bar model. So the first question, A, says, what is the total number of box tops the class can trade? Well, I need to go back up and look at my little problem. It says Mr. Soto's students can trade 75 box tops. So I'm going to write that number in the model up at the top. This is the total number they can trade. So 75 is going to go at the top. That's my largest number that I have. It's my total. Okay, and I'm going to write total here. B asks us, how many box tops does the class start with? And write that number in the model. Well, they have 49 box tops. That's how many they currently have. So that's the number they start with. So I'm going to put 49 there, and I'm going to write the word start there. Okay. And then the last part of that problem says, how many more do they need to get to 75? And that's, of course, our question mark. That is, how much are we going to change 49? What will our change be? What are we going to add to 49 in order to get to 75? That's the change, not money, but how are we going to make that number increase? So that's the change we're talking about. Okay, so step C says use the model. Fill in the blanks below to write an equation. Well, the first thing I'm going to do is look at what my equation is. It says blank plus question mark equals blank. I know when I'm adding the two parts. So a bar model shows us the two parts at the bottom. We have the two parts at the bottom of the model that when we add together, we can get the total. So our parts in this particular problem are 49 plus question mark equals our total of 75. Okay? And then it says to find the missing number and show your work. I want to go back and say, are we trying to find the start of this problem? Are we trying to find the total of this problem, or are we trying to find the change of this problem? You're right, we are trying to find the change. The change is the number we need to find out, this one right here, okay? So, the total is 75. We're starting at 49. We're going to change in some way to get to 75, okay? So our top number in the bar model is always our total, and then our two parts are in the bottom. I'm going to pause you go ahead and pause the video and find out what our missing number is, and show your work, please, either using a number line to show your work, or you could use equations to show your work, but try to find out what the missing number is, but please do not draw pictures of tens and ones. So pause the video now. Okay, I hope that you found a way to solve this problem, and it could be different than what I did. I did a number line, and I chose to do adding up. My arrows are going in that direction. So I added 1 to 49 because I wanted to get to the nearest 10, which was 50. So 49 plus 1 equals 50. Then I knew that my nearest 10 to 75 without going over was going to be 70, and there's that 10 right there that gave me the clue. So then I did 50 plus 20 more, got me to 70, and then I know I needed a total. My ending number was going to be 75, so from 70 to 75 I knew I needed to add 5. Then I just added those three numbers together over here, and I got my answer of 26. So I hope you solved the problem and found out that 26 is the correct number. Now, why do you think that how you solved it was a good way to solve the problem? I want you to think about that, and some of the different ways that you could have solved it was counting up like I did. Some people may have taken 75 and subtracted 49, and that would work as well. So, you know, when you're solving these problems, I want you to be also thinking about what are the best way. What do you think is the best way to go about solving the problems? We're going to now take a look at the next page, which is 81. And most of page 81 is just giving us some examples of how to solve one-step word problems, and we can use models to represent where a problem starts, how much it changes, and the total in the problems. So it's just an organizer. It's a way to organize your numbers so that you know what's going on and can figure out how am I going to solve the problem. In the previous story, our start number was 49 box tops. Our change was we didn't know how many more they needed to collect, but we did know that they had a total of 75. So that's how we knew how to fill in the bar model on the other page. And I'm going to go ahead and just put it over here. So we knew we could start at 49. We knew we could add an unknown number to get our total of 75. Okay? So bar models just are a way to organize our numbers. I would never take the numbers in this particular model and add 75 and 49 together. Never, because 75 is my total. So I know that 75 is the biggest number in this fact family. And you never add on to the largest number. The largest number is what your total is. So you can subtract away from it. We could have done 75 minus 49, or we could add up to it by starting at 49 and adding up till we get to 75. So in this area, it just shows that here's three different ways to model this problem. We have this first model here, which shows the total up above in this bracket here. We would put the total number there. We would put our start number here, and our change number would go there. Here's another model. This is the bar model that we're familiar with. The total goes in the top. The start goes over on this side, the left side, and the change goes on that side. And then here's a third model, and this is our familiar number bond, and the total goes at the top, and the start is over here on the left side, and the change is on the right side. What do you notice that is the same about all of these models? I want you to think about what is the same. So I think that a lot of you are thinking and telling me that in all three of these models, I can see that the total is the top number in every single one of them. And some of you may have noticed that the start number is always in the lower left-hand corner of the model. And some of you may have also noticed that the change is always located in the right bottom side of the model. So they are all the same in that way. And the way that they're different is just the way they look. This one has this little funny bracket here that connects our parts. This one here has all three parts organized in a rectangle. And then the third one, the number bond, has their parts situated in a triangle shape. So pretty interesting, huh? But they're the same, but they're also different. Okay, so now we're going to take a look at solving the problems using equations, all right? So we have some addition equations to look at for this fact family, and we have subtraction equations for the fact family. I'm just going to, over on the right side here, show you the three numbers that we have in our fact family. We have 75 as one of our numbers. We have 49 as one of our numbers. And we found out that the third number was 26. Okay, so that's the third number, or that was also the question mark number, okay? That's the one that was our change, our unknown. So using those three numbers, we know that we can create two subtraction problems, as shown here, or we could create two addition problems, as shown over here. So we're going to take a look at the addition problems. They start with 49 for the first one and add the unknown change, and our answer will always total up to 75. That's the first way. This way also shows that we could start with the unknown and add 49 until we end up with the total of 75. At our subtraction side, it shows that we could start at 75 and take away or subtract 49 and get the unknown number. Or another way you can use subtraction is by starting with the total again, take away the unknown, and end up at 49. So those just show fact family solutions to addition problems, to subtraction problems that could be used to solve the problem. Down here, the very last part, it asks us to look at the equations above. So they're talking about the addition equations and the subtraction equations. So we're going to look at those. It says the question mark and numbers are in different places. Why is the answer to all of the equations 26? In other words, why is that question mark always 26? So I want you to think about that. Why is the answer to every one of those questions 26? So pause the video and write your answer. Why in every single one of these problems, why is the answer to that question mark always 26? Pause the video and write your sentence. Okay, I hope you have written your answer, and hopefully you have something in there in your answer about fact families and how fact families is the reason why we're always going to have 26 as the answer to these particular equations. And your sentence will probably be totally different than what I wrote because we all think differently. But as long as you wrote something about that, you know, we know that fact families will be using the same three numbers, and that, you know, you can use those numbers to find your unknown. That will be fine. And I just wrote that the answer is 26 in all the equations because in a fact family, the three numbers are always the same. You use the two numbers you have to find the other missing number. And like I said, you don't have to have the exact thing written there that I did, but hopefully in your words, you wrote something about fact families and how they can help us find the missing number. All right, so that is the end of today's lesson, and I hope you enjoyed it. So we'll talk to you in the next video. Bye.